Hi there, guys. Well, welcome back. This is 5H. This is cumulative frequency. Um, to be honest, for most people will probably have seen cumulative frequency before, so probably the only new thing here is working out percentiles and potentially putting on box plots underneath your graphs. But really, the only extra thing compared to what's been in previous courses is percentiles. So I'll deal with that, and I'll deal with that through the question. And there's actually only one question before the exercise. And then they put on some hints as to how you construct one of these cumulative frequency graphs. So I'm going to kind of do things the wrong way round because of where you guys are. I'm going to talk about how do you find percentiles, and then I'm going to talk about how do you construct one of these graphs, just in case you've forgotten or if you've never seen this before. And then after that, I might put in as well, how do you work out a median from a table if you don't have a cumulative frequency graph? So cumulative frequency graphs are useful for being able to find medians when you have group data, and also lower quartiles and upper quartiles when you have group data. Okay, now, because I'm doing this kind of back to front, I expect that you know that already, but I'll come back to that. So what I'm going to do is just look at this question to begin with. And this is example 10. So the question says, the cumulative frequency graph represents the weight in grams of 80 peaches picked from a particular tree. And part A says, estimate the median weight of the peaches. Okay, well, the median value is going to be halfway through all of our values, all of our frequencies, the total of our frequency. We can see that 80 peaches is the total of our running total here, if you like, or our cumulative frequency. One way of talking about cumulative frequency is you can say that this is really an accumulation of your frequency throughout. So in other words, if I take a point here, let's take, for example, this point here. This is the point 110, 50. Okay, so that means to say that in terms of the weight of the peaches, there are 50 peaches which have a weight of up to 110 grams. So each of these coordinate points, you're going to put them into kind of regular everyday language. You say, well, we have 50 peaches which are up to the weight of 110 grams in this case. So at the end of this kind of running total, if you like, which will have been made from points, but we'll talk about how to make it in a bit. So at the end of this, you'll have this point here, we've got 150, 80, and that means to say that we've got 80 peaches, which are, remember, up to 150 grams. Now, seeing as we've got 80 peaches all accounted for there, we don't need to go beyond that. If we were going to take this graph beyond curve where we are at the moment, it would just be kind of flat, because it would also be true to say that there are 80 peaches which are up to 200 grams. There's 80 peaches up to 1,000 grams. It's just that we actually know that there's the 80 peaches are already accounted for up when we get to 150 grams. Okay, so when it asks for the median weight, we want to know what the where we get to in terms of our weight when we go halfway through the data. Well, 80 is the total, okay, and 40, actually 40.5 is the median. Now remember, you can do 80 plus 1 divided by 2 to get the value which you need, which represents the median. The result for this peach, if you have all of these peaches lined up in terms of their weight, so the value of the 40th and the 41st will represent the median. So, you know, you can imagine there's 40 on one side, there's 40 on the other side. These are lined up in ascending order in terms of their weights. And at the end of the 40th here, at the end of this first 40 is the 40th. Start of the next 40 is your 41st. Okay, and you can just take these two and take an average of those two results. Right. Well, we don't need to do that here. It's also because we can actually just draw a line across. Now, it's really difficult to draw a line across 40.5. So, although you can say that you're doing that, in truth, we can't really do much better than follow that line across and then follow it down. Okay, and obviously you're going to do that with a ruler, and it's coming out at something like, I don't know what that is, 114, 113, no, sorry, 103, 104, something like that grams. Okay, so the median is going to be there because we know we have 40 which are up to that point, and we know we have 40 which are at that point and beyond. But given that this is continuous data, you can just say that we're actually at that point, and also it's an estimate as well. So we don't need to worry too much about the finer points of the mathematics of this. We can just simply draw a line across and draw a line down. Okay, so there we go. So the median in this case is 103, 104. It's just find the middle value, draw across and draw down. So when we want the 40th percentile, which is probably the new thing for most people, we need to find what is 40% of the way through the data. Now, again, if you want to, just like we're doing the upper quartile is 3/4 of n plus 1. If you want to here, you could actually do 0.4 times by, again, 81 here. So you could make that adjustment. But again, it's really going to make very little difference because we can't really get any more accuracy out of this scale here. So it will be fine to do 40% of 80, which is 32. Okay, and so 32 is kind of here. If you follow that one across, you should actually draw this one across. We're getting to perhaps 100 or maybe 99 there. Okay, so that's maybe 99, something like that. Okay, 99 grams. Okay, so 40% of the way through the data, we should show our calculation. We're looking for the 30-second value, and the 30-second value is here. So let's say 30-second there, following that one across, and we're coming up with the answer of 99 grams. So in other words, there are 32 peaches up to 99 grams, and there are the rest of them, 48 peaches, which are beyond that. Okay, so that's the 40th percentile. And obviously you can do this for the 10th percentile, and the upper quartile can be called, or what we call Q3, can also be called the 75th percentile. That's meant to say percentile, okay, percentile, 75th percentile, you get the idea, okay? So there we go, we can find all the percentiles we want. Now it says estimate the number of peaches that weigh more than 100 grams. Okay, so more than 100 grams, let's find that. So let's go up to here. You can see we're getting this point here, and then that's coming across to around maybe 33. Okay, so there's 33 which are up to 100 grams. Okay, but then we want to know about how many weigh more than 100 grams. So our estimate would be the other ones. I mean, it's very difficult to get a peach actually exactly landing on 100 grams because we can zoom in and zoom in and zoom in. So we don't, again, that's what I was saying about that kind of finer mathematical point here. This is a continuous scale. So the fact that anything would be actually 100 grams would be almost impossible. Although calculations might have been rounded off to give you 100 grams. Listen, again, too much detail. Okay, so more than 100 grams is 80, take away 33. It's the ones which are above. Okay, so it's always useful to write down this up to when we're trying to convert it into everyday language. Okay, so that's percentiles. Now, I said that I'd talk a little bit about how to draw these things out. And so we're going to do that next. You can see the answers there. They're coming up with, I said 103, 104, they're saying 104. I said 99, they say 98. I said 33, they say 34. It's okay to be one out, especially in a situation in this graph where the scale is quite condensed there. It's quite a small graph. Okay, so yeah, I said I was going to just talk a little bit about how to make these graphs. I'm going to talk about this thing, an ogive. It's basically the shape of it. There you go, that's done. So we're going to talk about how to create these things. And then afterwards, towards the end, I'll talk a little bit about how to work out a median through interpolation from your table. Okay, so although that's not being discussed in this detail here, it's a potential question. How might you work out the median if you just had the table and you hadn't drawn the cumulative frequency graph? Okay, so that's what I'm going to mention here. If you find this is all really basic, then of course, stop up now, have a go at the exercise. The exercise, there's only 5 questions there. Oh, and by the way, in the exercise, question number 5 there was a former exam question. So part B to question 5 is a really nice question. I think that turned up in, I think it was something like a 15-mark extended question. So yeah, that's a part B I really suggest that you do from question 5. We'll try and think about that one. Okay, so how to make these things? Well, a lot of you will have made these things before. And what I've done is just come up with, found these set of exam questions here, exam style questions. I think these come from Maths for Everyone, that website. And if you have a look at this, they're giving you here a table. They're talking about 60 oranges here, not peaches, going to oranges. Doesn't always have to be fruit-based. And they've actually given you the cumulative frequency straight away here. Now, often what you get instead, let's just look at this one though as an example. So often what you'll get is, from 50 to 60, although they'll state it like this, from 60 to 70 and so on. You can see this is not as good as this notation, because here we actually know what to do with an answer of 60. Okay, so 60 to 70, 70, 80, and so on. Now, if you had here 60 to 70, 50 to 60 would still be a frequency of 12, but from 60 to 70 is the extra that you're getting here, because this is still starting with 50. So the extra is 30. Okay, so 50 to 60 is 12. 60 to 70 is 30. Our running total is 42 now. So you can go backwards from cumulative frequency tables to frequency tables by just finding out your differences each time, what you needed to add on. Okay, so if we added on 30, that must have been what was in the 60 to 70 category. If we add on 12, that must be what's in the 70 to 80 category. Okay, now when you come to the end of your cumulative frequency, that gives you your grand total that we care about. It's 60 oranges here. Was it 60? I thought it was 80. Maybe it was 80 in the other one. 60, okay. Right. Okay, so there you go. So that's what you'll normally be given, though, is that frequency table, and then you'll be asked to make the cumulative frequency. Now, the Oxford book is suggesting this is a very unlikely exam question, but I have seen these exam questions turn up before. It's just normally they're really easy starter questions or something, and they kind of surprise people because you don't expect this when you've been studying, all of your HL maths, for this stuff to turn up, which is actually, really simple and turned up in previous courses. Okay, once you've got your cumulative frequency, you can make your points. And the first point is always plotted at the end of the category. Remember, it's 12 up to 60. So you're going to be plotting 60, 12. Remember, we're saying 12 up to the top of this category here. Now, there's another point that we need to plot, and that's we know that there are none before 50. So we can write 50, 0. Now, it depends where if you know where the first value starts, because if you know where the first value starts, if it actually starts at the lowest value is actually 54, then you can actually start at 54 instead of at 50. And in a lot of cases, you'll actually need to just join it up to your 0, 0. Okay. And anyway, when you start plotting all of these points, you end up getting, here we go, let's just view this one. Once you plot all of these coordinate points here, which they've put on the end, you're going to get your curve, and they're talking about the curve being called an ogive. Ogive, if you like, ogive. So there you go. That's done. And there's the points which are plotted. And frankly, that's all we need to do there. We're always going to end up with this kind of flattened S-type curve here. So the thing can never go downwards because it's a running total. So it's always going to be something like this. It can be kind of a bit lumpy, bumpy on the way up. But generally, you're going to get coordinate points that are kind of S, and you don't join them up with straight lines. You join them up with a smooth curve because you're kind of making estimates for the shape of this distribution. So it's going to look something like that. Okay, well, there's drawing them, and there's kind of some hints in the book here as well. It says you can draw a box and whisker plot underneath. Okay, now that's pretty straightforward because once you've got your information, you know, there's your 60 as a total of the oranges in this case. We can go and say, well, look, our greatest value we think is at the top of this range. Our lowest value is at 50. Okay, so we've got 110 and 50 plotted there. Okay, and you can work out the median. So you can go down there, come up with a line for the median. Sometimes people use a dotted line, and you can come up with your upper quartile and your lower quartile there. And you can plot this and this, and then you can join it all up with these straight lines, and this is your box and whisker plots. There's your whiskers. Okay, sometimes these are just called box plots. And, you know, you should be able to talk about the comparison of two box plots. You know, if you get one which is, you know, like this maybe, okay, you can see that this is a kind of normally distributed, evenly distributed distribution. And if you get one which is kind of like, here we go, this, go all the way up to the same point, you can say, well, they both have the same range, but this one seems to have some kind of outliers in it. Okay, well, there's outliers because we're more than 1.5 of the interquartile range away over here. We can also say that, you know, this one is potentially more spread out. All of the weights of these oranges, or diameters of these oranges, are more spread out because we can look at the interquartile range over the range. And we can see the interquartile range is much bigger. So you can see that these ones are kind of skewed negatively as well, so skewed towards the start of the distribution. You can talk about the average as well as the dispersion. So you can talk about the average being whatever value that comes out as, and this is your median average here as well. So you can say, well, my average is this, and the other average is greater. So there's lots of things which you can discuss, and you know, you should put it in a real life context as well. Again, you know, if you've got two almost identical distributions, you know, let's put this one here and one sort of further down the line, shouldn't be this line here, right? Then, you know, when you're talking about the dispersion and when you're talking about, you know, the dispersion might be the same, the medians are different, but you can also talk about the lowest value difference and the highest value difference as well. Okay, so there's lots of little points which you can discuss. And remember last time round, they said CSOS. What did that stand for? That stood for center. That stood for spread. When we're talking about distribution, outliers, and shape. What's the shape of the distribution as well? Okay, so there's that. And the final thing I'm going to talk about here is if you were going to work out a median from this, okay, and you only were given the table and you weren't asked to draw this thing out. Actually, let's take a different table for this. So let's take the original table. Yeah, here we go. Not particularly nice numbers. Let's see if we can find something better. Here we go, this one here. So let's take this, talking about the age of 200 elephants. And if you wanted to work out the median of this and not make a graph, then what you could do is think that what we want is the 200 plus 1 divided by 2 value. Okay, that's what we're looking for the median. That's where the median is going to lie. So when we look at this data here, we've got 200 as a total. So when we look at the data, we've got here 55 up to here. We've got 115 up to here. And we've got 155 up to here. So we can see that 100.5 value lies in this category here. Okay, the question is, how far through to the category does it lie? Well, what we need to do is say, well, we've got 100.5, take away the 55, take away the start of the category. That's how far through this thing we are. Out of 60 as the total. So we're saying, what fraction of the way through the category are we here? So we're getting 45. What is this now? So we're getting 45.5 out of 60 of the way through the category. We can say that's through the class width or the category. Okay, so what we want to do is say, let's take that fraction of how far we are through the class width, and let's times that by the class width. So let's times it by 10, that's by the class width. So 20 take away 10 gave us that 10, which we're going to use there. And then that will give us how far through this we should be to find the median. And then we still need to add on the original 10 as well. Okay, so that will tell us how far through the distribution, how far through this category the median should lie. Is it near the start? Is it near the end? It seems to be about 3/4 of the way through. And when we calculate that, we're obviously going to get a pretty nasty number. And, you know, times by 10 plus on the original 10, and we're getting there 17.6 roughly. Okay. So 17.6. So the median is roughly 17.6 there. Now this is a technique of linear interpolation. It's not mentioned in the book, but I think that you should know about it in case you were asked to make an estimate. Okay, linear interpolation is what we've used there. Okay, guys. Well, thanks for listening in. I think I'll stop it there, and think you can have a go at the questions. Next time round is a pretty big one. We're talking about correlation, causation, and linear regression. Okay, so thanks for listening in, and hope to see you back for the next one.